Hello friends, welcome to my channel. In this video, I will going to talk about the most frequent approaches which are used to solve the problems in technical interviews of top companies. So let's start with the first approach, which is sliding window approach. It is used for arrays and string data types. So what happened in this approach is when you are given an array of let's take size some n, and you are given the starting index and the end index. So this is called your window for which you compute the result, and you shift the starting and end index to get new index new index range for which you compute the result. So in this way, this sliding window works. So let's take this example. Count distinct elements in each window of size k. So it is an example of fixed size. So what happens in the sliding window approaches, we have two types of things, fixed window or variable windows. So in this, the size is fixed. Here also the size is fixed. Here the length of the smallest subarray whose sum of the elements is greater than the given number. So its size is variable and its size is also variable, but this question size will be fixed, which is of pattern string length. Now let's start with another approach, which is greedy approach. In this, the solution is find out on the basis of getting it at the earliest way possible. That means when you are given a question, you have to select in an array, or we can say in a graph, which satisfy our question more appropriately. So here are some examples of greedy approach. First is activity selection problem. So when we are selecting our activity on the basis of whose value is greater, so we are just selecting the item whose value is the greatest among all the elements. Another is the fractional knapsack problem. Here we are given weight and price of all the elements, and we are doing price by weight to get the fraction of how much price per weight we get. So on the basis of that, we calculate our maximum profit answer. Another is Kruskal's minimum snapping tree, and another is policeman catch thieves, and other one is minimum number of platforms required for a railway bus station. Now let's discuss about the another approach, which is two-pointer approach, which are basically used to solve the questions related to arrays and strings. Arrays and strings. So when you are given, let's take an example of an array. You are given a pointer 1, P1 and P2, which are pointing to two different elements, and we compute the answer for these two elements, and on the basis of that we compute the temporary answer for these two P1 and P2, P1 and P2, and we shift these P1 and P2, either increase it or decrease it on the basis of our requirement for the question, and compute the answer for other indexes. Uh, so these are the examples. Trapping rainwater. In this, like, you are given an array of different sizes which are like heights. So you need to calculate how much water is trapped. So in this, here and here only the water is trapped. Similarly, there is a linked list, and you are given a linked list. You have to find if it has a cycle or not. Another example where two-pointer approach is used is valid palindrome question. Another is string compression, and another is threesome or threesome with multiplicity. So these are the examples where two-point approach is used. Binary search is another great approach used to solve a lot of interview questions related to DSAs. So in this we have sorted list, and we have to find some elements in that sorted list. So there is multiple examples. Let's take some 5 top examples which we can solve. Find a number in a sorted array. To find a number in an array, we can use two pointers, left and right, and one in the mid. And on the basis of that, we calculate for our mid value and the number which we are given. On the basis of that, we select which part is relevant to our answer. Another is first and the last occurrence of a number. So there are like multiple indexes which have the same number. So like this, for finding 4, we have a starting index is this and ending index is this. So we can find that from binary search also. Then another is cuckoo eating bananas. Another is find median of two sorted arrays and capacity to ship passengers within D days. Divide and conquer is another great approach to solve the DSA questions. So we are given some arrays or list. We divide that array into some parts like this, and then from these parts we divide them into another parts and solve and compute the results for these parts and club them to get this answer. And to get the final answer, we club all the divisions. So like in merge sort, we are given arrays. In that array, we have to sort all the elements present there. So we divide it into two parts and do recursion to find the to calculate the sorted array for this part and the sorted array for this part individually. And to sort this part, we subdivide it into two parts, right? And we then sort these two parts and then club these two parts to get the final result for this part. And then similarly for this part, we divide it to sub arrays and calculate the sorted path, and then add or merge, we can say, to get the result for this. And after getting the result for these two parts, we club these two to get our final sorted array. Another is closest pair of points problem. So for a particular points, there are multiple points x and y. Let's say a lot of multiple points x and y, x1, y1, x2, y2. So from these we divide from this to this and calculate which are close to this particular part. Another is Tower of Hanoi part, and another is strength algorithm. Recursion basically means it's calling itself inside itself. So recursion is like we are calling same method with different parameters inside it. It is used, recursion is mostly a lot used in trees, graphs, and arrays, and many more data structures. Another example is divide and conquer algorithms are also derived from recursion, like merge sort we talked about. So in merge sort we have some intervals L and R, so that L and R itself create merge sort on L comma mid plus mid, another at plus merge of mid plus 1 and R. So these two ranges, that means this merge function is calling itself inside this merge L comma R function. Another is backtracking approaches. So these are also recursions, but are from different from divide and conquer. Another is quicksort, and another is given a string print or possible palindromic partitions. So this is again a type of backtracking algorithm only, right? Backtracking is another example to find the solution of the question recursively and for all the possible answers, and if not matching our requirement, we backtrack or we undo our tasks to get to initial state and start from another part, right? So there are multiple problems like NQ problems, rate in a maze problem. So like in a maze, we have some barriers, some like walls, and red is starting from this point and he want to reach this point. So there are some rocks here, some rocks here. So that means red has two options like this direction, down direction or right direction. So when it comes here, when it goes to the right, there is a block, so it should not go there. Other it should change its location to here. If also here is a wall, then and it reaches here, so it has to backtrack to this point only to reach to the final location. So this is like backtracking approach. Another is night tour approach. Another is Sudoku problem. Another is graph coloring problem. So coloring a graph notes is also an example of backtracking algorithm. Dynamic programming is also using recursion in itself, but it optimizes the time complexity by storing the answers, computed answers, in some array, so that the time complexity or decreases. So like in Fibonacci series, it is F0, F1, F2. Similarly, so F2 can be calculated by F0 and F1. So we store these numbers to get the next numbers. Like for this F3, we can adjust at F2 plus F1 to get F3. So similarly for 0-1 knapsack problem, dynamic programming is used. Shortest common subsequence also dynamic programming is used to make it more efficient. Longest common subsequent also sequence also dynamic programming will help you move. For coin change problem also dynamic programming will help you move. So another great approach is top k elements. So it is now again a lot of time it is used by the interviewers in a lot of questions. So we can solve the question using this approach a lot of time in our interviews. So it's like we are using here some data structures like priority queue, right? So using priority queue, it can be solved very efficiently. So like here the smallest element, so you are given an array, we say, right? When you are given an array, you have to find the kth smallest element in that array. So what you have to do is just put the k elements in the priority queue and kth smallest element. So remove the maximum element from that queue and add another element to that queue, right? And store that part in our answer. After finding our answer for this window, when we go to this window, we know this is our appropriate answer, but there may be possibility that this also give us our appropriate answer. So we differentiate, like we compare both answers from this window to another window and check which is the smallest from these three, right? Similarly, from find k most occurring elements in the given array using counting of the frequency counting of the elements. K closest points to origin, similar most frequent even numbers, and find k pairs with smallest sum. Depth first search and breadth first search are used in graphs and trees. So this is again a common approach. These are the common approaches used in DSA questions. A lot of DSA questions are using this approach to solve the solution. So the one question is like find the number of island. You are given a grid. You have to find how many grids have 1 1 1 in common. Like 0 is the water, we can say, and 1 is the land. So how many island are there in this grid? So we can say one is this, another is this one. So it has two islands, right? So we can use BFS as well as DFS here to find our solution. Another example is print all paths from a given source to destination. Like from given source, some point is given, source is given, we have some destination in here. There are different routes, like it's going from some other country, other location, right, and coming here. So these are the paths, and I have to find all the paths which are going from source to destination. Find the minimum depth in a binary tree. Again, in a binary tree, you are given two left and right childs. So we have to find the minimum depth. Like in this, the minimum depth is 1 2 1 and 2. This is the root node, right? This is a leaf node. This is the root node and this is the leaf node, and this is the path, and the depth is 1 plus 1 2. Print right view of the binary tree. So again, right view is this, like this. Print root vertex in a graph. Like in we are given a graph, we find the vertex which is connected to all the nodes in that graph. So this is DFS and BFS. So it is also most used in coding questions, right? Bit manipulation. It is another great approach to solve the DSA equations. It is not that common though, but it is used to optimize our solutions. It is a very efficient algorithm provide the optimized solution to the questions. Like there is an example, check if a given number is a power of 2. You are given a number like we can say 5, 6, 5, 10. So we have to check which number is the power of 2 or which number is not. Using the bit manipulation, we can easily find the solution. Like for another example, count the number of ones in the binary representation of the given number. So you are given a number, we have to check like how many numbers are 1 in its binary representation. Now the other example is find the largest power of 2 which is less than or equal to the given number. You are given a number, you have to find the largest power of 2 which is less than or equals to that given number. We have to just find a greater number which is the power of 2. Another example, if a number is a power of 8 or not, we can definitely check this. Another is print all distinct subsets of a given set. So using bit manipulation, you are given a set like this. We can check, you have to find subsets, right? So we can just initially let's take all for all 0 means we are not taking that number, that index. So in initial that is empty set. When we check 1 for 1, one element is there. So it's another example is 1 0 0 0. So this is also a set taking only first ayat has a one element. So in this way we can find the different subsets of a given set. So these are the approaches which are used to solve the DSA interview questions mostly. These are the most common approaches which are used commonly. So thank you guys. This is what all I had. If you like the content, please like, subscribe. Thank you. Thanks a lot. Bye.